Bismillahirrahmanirrahim. We are going to discuss the development of our skin and the appendages of the skin, meaning thereby hairs, sebaceous glands, sweat glands, uh, nails, etc. But at the same time, at the end of the lecture, we'll discuss also the mammary glands. The rationale of discussing mammary glands, that would be clear when we reach at the discussion point of mammary gland. The skin is the largest organ of our body. Its surface area nearly is 2 meters square, and it forms 6% of the body weight. As previously spoken, anatomically, the skin also includes its specialized derivatives, that is hair, nails, sebaceous glands, and sweat glands. Histologically, the skin consists of epidermis, which is 0.2 millimeter thick, and dermis, which is 1.2 millimeter thick. So the thickness of the epidermis and relatively thickness of the dermis. Epidermis is only 0.2 millimeter and dermis is 1.2 millimeter. Embryologically, the skin is both ectodermal, epidermis, and mesodermal, that is dermis. So embryologically, skin is both ectodermal in origin and mesodermal in origin. Ectoderm forms the epidermis and the mesoderm forms the dermis of our skin. Now it should be clear, epidermis is renewed after every 15 to 30 days. The epidermis is removed, which is existing after every 15 to 30 days, and the new epidermis is formed. Now see during development at the week 4, the thickness of the epidermis and the thickness of our mesenchyme, only the ectodermal cells are present on the surface, and a very thin layer of mesenchyme is present just below that. In week 7, another layer is added superficial to the ectodermal layer or single layer of cells, and this layer is started to be called as basal layer. So at week 7, it consists of 2 layers, periderm, which is flattened layer of cells, and basal layer, which is columnar layer of cells. At 4th month of uterine life, an intermediate layer is added between the periderm and the basal layer. You see over here? And finally, at the birth of the baby, there are multiple layers in the skin. If we go from here up, it would be stratum basale, which is also known as stratum germinativum, then stratum spinosum, then stratum granulosum, then this clear layer, which is shown nothing over here, stratum lucidum, and finally at the top, that would be stratum corneum. See the section of the developing skin during the 5th week of intrauterine life, ectoderm, mesenchyme. This is the uh, seventh week of intrauterine life. Periderm, basal layer, and then uh, fourth month of intrauterine life, an intermediate layer is added between the periderm and the basal layer. And finally, at the time of the birth of the baby, all the layers are present. Uh, Stratum corneum, stratum lucidum, stratum granulosum, stratum spinosum, and stratum germinatum in the epidermis, and below that is the dermis. We'll discuss. So, we'll start discussing how the epidermis is formed. You have seen the pictorial view. Now we'll go a little more detail. Now the epidermis at the age of first month of intrauterine life, it is consisting of a single layer of ectodermal cells which is the simple cuboidal epithelium. At 1 month of age, during intrauterine life, the epidermis consists of single layer of cuboidal cells derived from ectoderm. During the second month of intrauterine life, the epidermis changes into two layers. Periderm, consisting of simple squamous epithelium, and basal layer consisting of single layer of columnar epithelium. During the month 3, an intermediate layer is added between the periderm and the basal layer. This is intermediate layer. Now this layer, which is basal, is mitotically active, meaning thereby it gives rise to the cells which move up to add a third layer between the periderm and the basal layer. Now we can call it as stratum germinatum. So during first month, it consists of single layer. During second month, it consists of two layers. And during third month, it consists of three layers. Easy to remember. Afterwards, it is increasingly stratified and specialized. At birth, all the layers of the epidermis are present. The periderm undergoes keratinization and desquamation. New cells are added from the underlying basal layer known as the stratum germinatum. So the topmost layers is known as the stratum corneum. The cells over here they are keratinized and they are removed by desquamation. Now, generally speaking, the cells of the epidermis, what the cells of the epidermis are histologically. Now, in the epidermis, you also see melanocytes. What they are? These are the cells which migrate from the neurotic cells to the basal layer in the early fetal period, and large amount of pigments is not produced until the late fourth month of intrauterine life. This is for the pigmentation of our skin. The rest are the keratinocytes. These are all the cells of the epidermis are the keratinocytes. Originate from the basal layer, move up, add successively to the above layers. As they move up, They are filled with keratin granules. More and more granules are there as they move up from the basal to the top layer. By the time they reach the stratum corneum, they, they are full of keratin and they lose their nuclei and they are shed away by desquamation. Langerhans cells, these are derived from the bone marrow. They arrive in the epidermis in the third month of intrauterine life. They are considered to be peripheral components of the immune system. They function in cooperation with the T lymphocytes. From early pregnancy to the adulthood, their number increases from 2% to 6% of the epidermis cells. Finally, the Merkel cells, their origin is not clear. Evidence for both epidermal and urocrest origin appear in the epidermis around 8 to 12 weeks of intrauterine life. They act in association with free nerve endings as slow adapting mechanoreceptors and possibly as neuroendocrine cells. So in the epidermis there are cells known as keratinocytes, melanocytes, the the Merkel cells and the Langerhans cells. These are in broad the cells of the epidermis. Now we go to the dermis. Now the dermis of our skin is derived from two sources. Dermomyotome. The somites, they divide into sclerotome, dermatome and myotome. So our dermis is derived from the somites. And which part of the somite? That is dermomyotome. And also lateral mesotome, which is going to divide into somatic and visceral mesotome. The lateral mesotome, it also gives rise to the dermis of our skin. But in the face and in the neck, our dermis is derived from the neural crest cells. That could be a question of MCQ. The skin of the face and the neck is derived from one dermatome, two dermomyotome, lateral mesotome, neural crest cells. The answer would be neural crest cells. The rest of the skin is derived, of course, from the dermatome and the lateral mesotome. To begin with, the dermis is loosely aggregated mesenchymal cells interconnected by tight junctions. They secrete watery extracellular matrix containing glycogen and hyaluronic acid. In the third month, the mesenchymal cells over here in the dermis, they differentiate into fibroblasts for collagen and elastic fiber production. The dermis dents or it elevates at spots into the epidermis. These elevations into the epidermis or projections of the dermis into the epidermis, they are called dermal papillae. The epidermis also dents the dermis. So that extends downwards as projections, finger-like projections, say broad finger-like projections. They are known as the epidermal ridges. So the dermal papillae are elevations upwards of the dermis, and the epidermal ridges are the downward projections of the epidermis into the dermis. So we have discussed until now the epidermis and dermis. Now we are going to discuss the appendages of the skin, and the first we will discuss the development of hairs. They are present on whole of the body surface except palms, soles, dorsal surface of the distal phalanges, prepuce, glans, clitoris, labia major. So these are the places where the hairs are not present. And on the rest of the body, the hairs are present. They are ectodermal in origin. Each hair has got a root embedded in the skin and a shaft projecting from the surface of the skin. Each hair has got a root embedded in the skin and a shaft projecting from the surface of the skin. The root is enclosed in a hair follicle, and it consists of an epithelial covering and a connective tissue covering. So hair follicle consists of both the epithelium as well as of connective tissue. So that is the epidermis. To begin with, it forms a bulb-like projection into the underlying dermis known as the hair bud. It forms further globular. It is labeled as hair bulb. It further goes down, and the lower portion of this projection into the dermis that elevates. It forms the hair papilla. From the top of the hair papilla hair goes upward. And this follicle consists of an epithelial covering and a connective tissue covering on all round. It is given attachment with smooth muscles, smooth muscle cells known as the erector pili muscle. They are attached to the outer side of the hair follicle at this point and up to the epidermis, say over here. And their contraction, they pulls the root towards it, thereby erecting the hairs on the skin of our surface during sympathetic stimulation. You must have noticed it. Okay. Another picture. A during the 4th month of intrauterine life. B at the 6th month of intrauterine life. And C at the time of the birth of the baby. That is the hair bud, hair papilla, epithelial root sheath, and dermal root sheath. And this is the smooth muscle fiber known as the erector pili muscle. Okay. Now we go a little more detail. The first rudimentary hair, they grow in the 9th week of intrauterine life on eyebrows, upper lip, and chin. And at other places during the 12th week of intrauterine life. So at first they appear in the ninth week on the eyebrows, upper lip and chin, and afterwards on the 12th week on the rest of the body. First evidence of the future hair growth is the clustering of stratum germinativum of the epidermis, which extends into the dermis as a hair bud. So stratum germinativum grows down as hair bud. The deeper part of the hair bud becomes globular, and we start calling it as hair bulb. The hair bulb is invaginated by mesodermal tissue known as the hair papilla. The cells at the apex of the hair papilla, they start proliferating and grow towards the surface. They keratinize and become the shaft of the hair when they project on the surface of the skin. The peripheral cells give rise to the epithelial root sheath and the mesoderm around that forms the dermal root sheath. Midway in the fetal life, melanoblasts migrate into the hair bulb and start producing melanocytes, and these inject melanin into the hair forming cells. Smooth muscle fibers, erector pili, develop from the mesoderm and attach the dermal root sheath to the papillary dermis here. Such muscles are absent in the eyebrows. Now the sebaceous glands. These are the glands which are present in all of our body, especially on the face and the front of the chest and the upper part of the back, but present all over the body for the softness of the skin, because it produces an oily material which suits our skin and maintains fluid contents beneath. Thereby, the loss of the fluid is prevented, and the skin remains full of water. Now, histologically, the sebaceous glands are simple alveolar or branched alveolar glands. Their excretory ducts open into the neck of the hair follicle. In the margin of the lips, nipple, glans, prepuce, and in the labia minora, their excretory ducts open directly on the surface. So thereby, what you understand is that the majority of the sebaceous glands, they pour their secretion into the neck of the hair follicle, and where the hair projects from the surface, their sebaceous secretion also is poured out from the same place. But at the margin of the lips, at the nipple, glans, prepuce, and in the labia minora, their excretory ducts open not into the hairs but on the surface of the skin directly. Perfect. So that is the sebaceous gland. Here, this one. Most of these sebaceous glands develop as buds on the outer epithelial root sheath of the hair follicle in the 5th month of intrauterine life. That bud grows and forms a lobule. The central cells of that lobule disintegrate, resulting in a flask-shaped sac. The basal cells of the sac are continuously reproducing. They keep on supplying new cells throughout life. They migrate inwards and dissolve in turn to produce sebum. So they are the holocrine glands, meaning thereby the cells destroy themselves for the secretion of the gland. They are the holocrine glands. Now the sweat glands. Sweat glands are of two types. Eccrine sweat glands, present on all over the skin surface. This is their number variation. The coiled tubular glands. Secretory coils of the glands lie deep in the dermis or in the subcutaneous tissue, while the excretory ducts lie in the upper part of the dermis and in the epidermis. The eccrine sweat glands, they develop first on the palms and soles in the fourth month of intrauterine life as cylindrical cord-like downgrowths of the epidermis at the summit of the epidermal ridge, like this. The deeper end of that cord coils in the sixth month of intrauterine life. So from the epidermal ridge, cord of cells grows down straight into the dermis, the deeper portion of that cord of cells. They coil themselves, they twist themselves and form the secretory portion of the gland. Just see. In the seventh month, tiny spaces or clefts they appear between the cells of the cord. These spaces join together to form a lumen along the whole length of the cord of the gland. The cells around the lumen of that cord, they form the gland cells. Some of the peripheral cells transform into myoepithelial cells. Intraepidermal portion of the sweat duct is formed likewise by unifying clefts among the cells of the epidermis. So the cells of the epidermis grow from the epidermal ridge as a cord or column of cells. The lower portion, the deeper portion, coils, that is the secretory portion of the gland, while the rest is the duct of the gland. Part of the duct is present in the dermis and part of the duct is present in the epidermis. Now the cells of the epidermis, they produce clefts or spaces which join together to form a duct inside the epidermis. They become functional in the seventh month of intrauterine life, but of course not needed until after the birth. Now the apocrine sweat glands. What the apocrine sweat glands are, that their secretions are produced by pinching of the portions of their forming cells with cytoplasmic contacts. So apical portions of the secretory portions of the sweat glands, they pinch off from the forming cells, and the cytoplasmic contents, they are there inside the gland as a secretion of that gland. The ducts open into the neck of the hair follicles. above the sebaceous glands. Okay? Eccrine sweat glands, they open directly on the surface of the skin. But the apocrine glands, they produce their secretion by pinching off the portions of their forming cells and open into the neck of the hair follicles above the sebaceous glands. Such glands, apocrine sweat glands, are present in the axilla, perianal region, and the areola of the breasts. So the glands in the sweat glands in the axilla are of apocrine type, and the cells of the perianal region are also of the apocrine type, and the cells of the areola, the glands in the areola of the breast, they are also apocrine sweat glands. Develop in the 4th to 5th month of infant life from the side of the developing hair follicle. Now, a point to be noted over here. The mammary glands and the glands of the external acoustic or auditory meatus, they are the modified apocrine sweat glands. So, this would be the rationale of discussing the mammary gland here alongside the development of the mammary glands are peculiar to the mammals. They are modified apocrine sweat glands, ectodermal in origin. The first sign of mammary gland development is a band-like thickening of the epidermis called mammary line or mammary ridge during the 6th week of life. We'll just show the picture. That line extends between the bases of the upper and the lower limb buds on the ventral surface of the trunk on each side. Only a small part of this line persists in the thoracic region, while all the rest finishes. The persisting mammary ridge proliferates and penetrates underlying dermis as primary mammary bud. So this is the first evidence of the development of the mammary gland on the ventral aspect of the developing body, thickening of the epidermis, thickening of the skin in a linear band-like fashion known as the mammary line on either side of the midline. This is the adult position of that mammary. The first, the epidermis would develop a mammary bud, then secondary mammary buds, and then of course lactiferous ducts. This one, the pit, and finally the nipple at the top. We'll discuss it. Okay. Same, mammary ridge proliferates downwards as the forerunner or as the evidence of the developing mammary gland. Lactiferous ducts, epithelial pit, that mammary line, and the position of the accessory nipples if there is abnormality. So this is the same line in the lower in the animals, like in the cat and the dog. They have got many mammary glands right from the forelimb to the hind on the trunk on the ventral side. Okay. Each primary mammary bud soon give rise to several secondary buds. You have noticed They give rise to 15 to 20 solid cords of epithelial cells, which canalize to form lactiferous ducts, and their tips they give rise to the alveoli of the future mammary glands. These lactiferous ducts open into a small depression of the epidermis called mammary pit. Shortly after birth, this pit transforms into a nipple by proliferation of the underlying mesenchyme. Mammary glands are identical in both sexes at birth. In males, they remain underdeveloped, but in females, at puberty, after pregnancy, during lactation, they undergo hormone-dependent developmental changes. The characteristic hemispherical shape of the female mammary gland is due to the deposition of fat. Finally, the nails, ectodermal in origin, develop from the epidermis. They correspond to the claws and hooves of animals. Nail plate, which is visible on the tips of our fingers and toes, that is hard keratin with high sulfur content. The hardness of nail is related partly to its structure and partly to its shape. Slight curvature both longitudinally and transversely. So that is, say, if that is the thumb or the big toe. This is the nail. That is the nail plate. If you see your fingers, you will see a whitish circle proximally. That is known as the lunule. And this is the proximal nail fold underneath which the root of the nail lies. We'll just discuss it. Okay. This is the longitudinal section. This is the nail plate. That is the nail matrix. From here the nail grows forward. And this is the proximal nail fold. Part of the skin lies over here as well. We'll just discuss. Okay. What is lunule? It is a whitish crescent on the proximal part of the nail plate in some of the nails. Why it is? It is due to incomplete keratinization and looseness of the connective tissue of the nail bed over there. Nail development begins in the 10th week in hands and 14th week in feet, and by 20th week all nails are completely formed. At the tip of each digit, epidermis thickens to form nail field. Tip. Then they migrate to the dorsum of each digit. The adjoining skin overgrows the nail field to form proximal and lateral nail folds. Underneath the proximal nail fold, epidermis cells, they proliferate to form nail matrix. The cells here undergo specialized keratinization without passing through keratohyalin and alidine stage. Special keratin fibrils that develop within the cells of the matrix. These flatten and consolidate into a compact tissue known as the nail plate. Such a nail plate is produced up to the distal edge of the lunule, beyond which the nail plate merely shifts over the nail bed and reaches the tip of the fingers 1 month after birth. The nails themselves, they correspond to what? The thick stratum corneum. The nails themselves, they correspond to thick stratum corneum. While the renewal and nail root, they correspond to the stratum spinosum and stratum basale only. Meaning thereby the other skin layers are absent. Only stratum spinosum and stratum basale. The nail bed is made of stratum spinosum, stratum basale, beneath which lies the dermis, which is thrown into longitudinal folds. A few of the abnormalities in relation to the skin albinism. You must have noticed many persons in your surroundings uh, who lack pigmentation on their skin and their eyes and their hairs and cannot open their eyes in the shining sun because their eyes do not contain the hair pigment. There is complete lack of pigmentation due to the failure of the melanocytes to produce melanin. Ichthyosis, this is dryness and the scaling of the skin due to disordered keratinization. Atrichia congenita, it is a complete absence of hair due to the failure of these follicles to develop. The person you will come across would not have hairs. Hypertrophic trichosis is the reverse condition where you see many more hairs on the skin due to the excessive development of the hair follicles. Abnormalities of the mammary gland: athelia, absence of nipples; amastia, absence of mammary glands due to the failure of the mammary ridge and mammary bud to form. Athelia, absence of nipple; amastia, absence of mammary glands. Polythelia, extra nipples; polymastia, extra mammary glands. The character of the dogs and cats sometimes is visible in human beings as well. Gynecomastia, excessive development of the male mammary gland associated with some syndromes like the Klinefelter syndrome, or due to the administration of the certain drugs which produce gynecomastia, their long-term use, after long-term use. Nails, anonatia, the nails are absent due to the failure of the nail cage to figure out. With this, we reach to the end of our lecture. Although lecture is long, but if you listen carefully, read carefully, open the book and study, I hope you will learn. This picture is given for some message. See the lady and her daughter. She has got umbrella, but the shadow is not on herself. The shadow is on her baby. So the mama thandiyan chha. Thank you very much.